Okay, so what do we have? We have two circles. One of them has radius 12. The other one has radius 8 units. And the distance between the centers is 13 units. So a good picture is essential, especially in this particular case. So we have two circles in the plane, and the question is, like, what do they look like? Is it possible that they look like this? And the answer is probably not, because for that to happen, this part is 12, this part is 8. So for that special case of external tangency, that happens when the distance is 20. Now 13 is smaller. So we gotta push these two circles together. So most likely we have something like this. Well, one of the circles is bigger than the other. So if this line that I'm marking orange is 12, then there is one left from the 13. So this is not a bad picture. Only, well, if this is 1, then the other 7 is in there. So this circle should probably be bigger, more like this. You heard me saying many, many times that a good picture is worth the hustle. So why does that matter? Because the problem says, well, they're common tangent line. That's a little sloppy because this this arrangement has 3 common tangent lines. Right? This arrangement has only 2. And the reverse, if the circles are like so, then besides these external tangent lines, there is this other funny ones. And so if this is the picture, then the problem is ill-defined because it just says the 2 common tangent lines. Well, there are 4, but we have this picture. And so there are only 2 common tangent lines. Each circle has many, many tangent lines. And then 1 or 2 happens to be a tangent to the other circle. Okay. What is the question? That's always a good thing to know. What is the distance between the point that's not even in the picture, the intersection of the 2 tangent lines from this center? What happens is that if the 2 circles are not very different in size, then this thing can go for a long, long time. You see now that I made the second circle much smaller. But now the picture is sloppy. So it's good to know that this is pretty much the picture we have, but this one allows us to actually see the part that's off the picture. Fortunately, it's not that good of a picture. So what's going on? First of all, this whole thing is symmetrical to the line that we get if we connect the 2 centers. So this point is on it, and we're just going to deal with 1/2 of it. So the one thing we know about tangent lines run to a circle is that they are perpendicular to the radius drawn there. So the points of tangencies, when we connect it with the centers, those 2 are perpendicular to the same line, so also parallel. And what we're dealing with now is 2 similar right triangles. Here is one, and here is the other. Going back to the picture, that's more like the situation we have. The smaller right triangle is this one, but this is the distance that is being asked. And remember, this is 13, and this is 8, and this is 12. So that's kind of enough. If you look at the radii are known, and then we know a lot about these sides. So maybe we need third picture. The picture is worth so much. Okay. Okay. So what do we know? This distance is asked. And then we know the smaller circle has a radius 8, the bigger circle has radius 12, and we know that this line segment here between the centers is 13. And that pretty much does it, except you have to be careful because 13 is side of neither triangle, right? There is one here that this side is 8, this side is x. And the corresponding sides of the big triangle, this side is 12, but this side is 13 plus x. You see? That's where students make the mistake. So we can say 8 over x, and it's kind of easy to set up the ratio because the corresponding sides are parallel, equals to 12 over not x, but x plus 13. And then we might realize, oh, we were kind of clumsy because look at it. Both unknowns are in the denominator. Something nice about ratio problems that come out of similarity is that everybody is positive. There's no worry about division by 0. So we can just take the reciprocal of both sides. So x over 8 is the same as x plus 13 over 12. We can cross multiply. Let's do that. So 12x is 8x plus 8 times 13. 104. So 4x is 104. And so x is, if this was 100, it would be 25. So it's 26. Now, this might seem a little too large, but that's why it's good to understand that probably this is the picture that we're looking at. And also, my favorite moment is when we go and check it for ourselves. So here is the problem, and the answer is 26. That's always very encouraging. All right. Thank you for watching.